Let's solve this problem.
Well, I like telling my students, if you need to solve a problem and you know what to do, it is not a problem, it's a task, you just do it. The problem is when you need to find a solution and you don't know what to do. And in this situation, a specific thinking strategy helps to construct the solution.
All right. So, well, this is what this problem about. How we use the general steps for solving any problem in physics. What objects are involved? Well, the object is you. Yeah. Well, we can draw a person, or does it matter how tall or how short the person is? Name, age? No, it is just an object. So in physics, simplest representation of an object is a dot. And it's been moved. How? Well, west. And then south. That's the picture. You should have that picture. Even if it's an obvious situation, it trains your brain in a certain way. So now, total distance. Now we have to apply a definition. What is the distance? The distance is a length of the trajectory. All right. Do we see a trajectory? Yes, we do. The trajectory is composed of two displacements. 1, 2. What is the length of this line? Well, 4. How do we know it is a 4? How do we know it's 4? Hmm? Well, it's on a screen, but if you didn't have any eyes and you couldn't see and you couldn't read, yeah, so there are more things involved. We have to recognize a number. And then, finally, what does total mean? This word means a specific mathematical operation, which is what? Add. So 4 plus 3 equals 7, you see? That's how it works. Well, this is my question now. I like when a question is very clear, unambiguous. So I write, what is the magnitude of the displacement? But every single textbook would ask, what is the displacement? They would miss the word magnitude, but they would mean it. Is this a simple problem? What do you think? Is it a tricky problem? Is it a direct problem? These are questions which kind of popping up in my head when I read a problem. You know, have I seen it before? Or something similar? Well, the first step usually is to read, but there is reading and there is reading. There is difference how an expert reads and how a novice reads. The expert, when reads the text of a problem, analyzes the meaning of each word, separates, okay, this means this means this. So there is a kind of a bubble above each word, invisible bubble, with the meaning of that word inside it. Well, here you're absolutely right. The next step would be drawing a picture. And that picture, well, of course, first shows your path. So this part is no different from what we've done just 2 minutes ago. It's still you. You still walk 4 meters in the same direction. Then you make a turn and you go 3 meters south. So this part is exactly the same. That's question number 2. 5. 5. 5. I'm glad you selected 5. That is the correct answer. But from this picture, we can't yet prove that the answer is 5. What is missing here? That element we are looking for, a displacement. This word represents something, so immediately our brain starts searching for the exact definition. Exact definition of displacement is a vector which connects the initial and the final positions. So this vector is still missing, and we have to add it to the picture. So that's the initial position. That's the final position. We just have to draw a straight line and add a pointer. Now, the magnitude of this, that's what we're looking for. A standard, well, there are several letters people use for displacement. Some different textbooks use different notations. It could have been S or D or L or delta S, et cetera, et cetera. It doesn't matter. We can use a word. Magnitude of displacement is equal to question mark. Now, how did you get from 3 and 4 to 5? What did you do? What did you do? If you think it's you, it's you. You did a Pythagorean theorem. Why? Well, would you use a Pythagorean theorem for this kind of a triangle? So that's how our brain works. Our brain is a very powerful pattern recognition machine. We have to train it to recognize patterns. That had been trained. If you see a triangle, it's a figure of a given shape. And if one angle in that triangle is equal to a 90 degrees angle, that's a right angle triangle. What do we know about right angle triangles? Pythagorean theorem, okay. A squared plus B squared equals C squared. What else do we know about right angle triangles? Yes? Not necessarily. This particular is, but it could have been a different set of numbers. This is 3, 4, 5 triangle because of the Pythagorean theorem. What else do we know about right angle triangles? Yes? Trigonometry, exactly. If we know two sides, we can calculate a sine or cosine or tangent of the angles inside. We also know that, well, since it's a triangle, the sum of all angles equal to what? 180. So we know a lot about right angle triangles. So, and, well, there's one single word which answers this question. Everything. That's what we expect to know about right angle triangles. We know everything. This figure of this shape is a heavily used in physics course. We're going to use it maybe every other day or so. So it's a good idea to refresh, if you need to refresh, all knowledge currently collected about right angle triangles. So the Pythagorean theorem, how angles and sides are related, and these equations also can be used backwards. For example, if we use this equation, we can calculate the angle using the inverse function, etc., etc. So please refresh this knowledge.